You have to share your screen.
I already had. Have it now.
Yeah, now you're there.
Now I'm sure you can see it.
Yes.
I'd like to thank very much the COREP Trust and also Mumbai Kidney Foundation for inviting me to talk. You'll note one change in my title is that I haven't said from design to implementation. I put down validation because it's very relevant to the ISO 23500. And the fact that I know that in India, your government is working towards the water treatment system, in particular the reverse osmosis system, becoming a medical device. They've been a medical device in most other countries for 15 to 20 years now, but your government has mandated that the devices used for dialysis should be a medical device. So a lot of my talking is based around the ISO. The other point is, I'm sorry, I don't speak Hindi. I only speak Australian. So you're going to have to put up with my accent. So I'd just like to bring up, first of all, that Fresenius, we believe in compliance and we believe in doing business in an honest and to abide by all laws and company policies and also all government laws. One thing about water treatment is that if we don't prepare, by failing to prepare, you are preparing to fail. And that's from Benjamin Franklin. And all of this can be attributed to good planning. I heard earlier on about can people in India afford a Fresenius water treatment system? My talk is not about Fresenius water treatment equipment. It's about the process of water treatment and providing a device that is a medical device. So I'm not going to talk long on the ISO because we've already discussed that today, but you saw the 5 components of it. And the ISO is the 2019 version that we work to. I will bring out a couple of slides from the ISO. And the first one is about validation of the system. So any medical device and any water that's used for injection has to be validated. So the system needs to be validated. So we need to do things like assign operational responsibility, assignment of clinical responsibility, assignment of legal responsibility. We need a validation plan. So the validation plan is your water testing, how you're going to do your daily logs. We also need to have installation, operational qualification, performance qualification. And if we do anything, we should re-validate regularly, and particularly if we change any steps of our process. Validation is the act of making something officially or legally acceptable or approved. This is a validation plan. So we assign responsible persons, we plan the activity, and then we go through this process of IQ, OQ, PQ, which I'll talk more about. And IQ is installation qualification, OQ is operational qualification, and PQ is performance qualification. So these are all key steps to installing a water treatment system. So even one of your local companies in India, they should have a plan that's based around so that they have installation qualification documentation, they have operational qualification, and they also do the performance qualification. The performance qualification then becomes part of the dialysis clinic itself to make those, once it's handed over from the company, that you continue that process. So we go through a process of project planning. And the project planning involves all the equipment, consulting and planning, our quality services, so our water testing, and also our biomedical technical in regards to looking after the water treatment system once it's installed. In Fresenius, we do have a standard operating procedure, and I've seen this in other talks today. And this is our step through from the moment we get an inquiry from a customer right down to the part where we actually bill you. There's a process of who is handling this process and checking proposal, doing the design, and making sure that we're following our own SOP for our project planning. So preparing to install a validated system is number one, your consultation with all key stakeholders. We've seen in several slides today that the nephrologist or the physician in charge is ultimately responsible. So they're at the top of the list to make sure that we consult with them to make sure that all their requirements, what type of dialysis they want to perform, what is their interest in green dialysis. So if they are, do they not want to use chemical anymore? Do they want to use heat disinfection? We also talk to the nurses to see what type of system they believe. So what connections they want on the back of the machines. We talk to the biomedical team to make sure that we know what dialysis machines are running. Is there reprocessing? Is there concentrate mixing? And we also talk to the operational team. So the operational team might be the team that one is handling the finance, two is handling the infrastructure like the power, the water, the drainage. We then need to, from there, develop our criteria list. So I heard earlier on, and I know that we all know very well in India, water quality sometimes is not as good as it is in Australia. So we have to take the feed water quality into account when we're designing. How many dialysis points? Is there reuse or concentrate mixing? Plant room dimensions, locations, dialysis ward location and services, and technical requirements such as, do you want a single pass RO or dual pass? And the interesting part about deciding whether you want a single pass RO or a dual pass RO, you can still have ultra pure dialysis fluid from a single pass reverse osmosis system. Provided that you have a ultra filter on your dialysis machine, you can still have ultra pure dialysis fluid for your patients. Dual pass is generally there if your water quality is very poor or if you want redundancy. So if you have a breakdown of one RO, the second RO. So that's what's important to note when the technical requirements that we figure out how many stages of osmosis. We also have our disinfection method. So are you happy with just cold sterilants or heat disinfection? So with cold sterilants, there is a risk in water treatment. With hot disinfection, we mitigate a lot of those risks. But as we know, they cost more and they do use more power at the end of the day. Once we have those, we design our system. So once we get our feed water quality, we can then design the pre-treatment. So I know in India, a lot of the time, the water hardness is a very big issue. So it might require 2 softeners, or it might require an industrial reverse osmosis system to lower that hardness level. Once we have all our number of HD points and our reuse and our concentrate, we can size the pre-treatment and the reverse osmosis system. Plus also we can start to design our distribution loop. We then look at our plant room dimensions. So from our operations team, we'll review, is there any additional works? So is there enough water and drains in the room? And are there additional power requirements? The dialysis ward location. So we need to consider the length of the loop. So particularly if we have very, very long loops, we can have a very high pressure drop. And it also means that sometimes we'll lose water flow. And if we don't have sufficient water flow, we'll have the creation of biofilm. The final thing that we'll find is from the technical requirements, whether it's dual or single pass or disinfection method, we can do our final selection of our reverse osmosis equipment. So for this plant, do we need a raw water tank? Yes or no? Do we need a booster pump? So if we have a raw water tank, we definitely need a booster pump. If we don't have a raw water tank, we may not need it. There may be sufficient flow and pressure. We should have some sort of media filter. So it can come in the form of a sand filter or a berm or a multimedia. We can have a cartridge filter as well to remove more of the suspended solids. Water softener. So in this case, we selected a dual water softener. So we have continuous supply of soft water. Carbon filters, as we know, the ISO says that we should be using 2 carbon filters in series, as the first filter is the worker and the second filter is the backup. We then have cartridge filters, which protects from any fines coming from the carbon filters, or it's the final protection to the membrane from any very small suspended solids. And finally, we have our reverse osmosis system. In this case, we have a dual pass system. We have a hot disinfection system and our distribution loop. The first thing that we do once we get all of this equipment sorted out, the first thing that we do is we actually make sure that everything fits in the room. So we provide a drawing to make sure that we have access to get the equipment in, that the equipment is not too crowded, that we have access to switchboards and so forth. We then work out, do we have all our requirements? So in this case, all our electrical requirements, all of our water supply, so our drain in the corner, our reverse osmosis system has the water outlets to the loop. We then also need to check that the floor loading. So we provide a drawing which has weights on there. And again, this is all a supplier should give you, because we have had a situation in the past where water treatment system has been installed, come in the next morning and the floor had cracked because the floor was not sufficient to carry the weight of the equipment. So you can see that one carbon filter, for example, is 335 kilos once it's full of water. That's a very small area of weight. When we order a dialysis machine, we may have only 11 lines here. So this is for a 5008 dialysis machine. We have, in this case, a BTM, blood temperature monitor, the type of cable we need. But when we're ordering water treatment, there's a lot of lists. So this is just for our pre-treatment, for our reverse osmosis system, and for our loop. So there's many components which make up the system for water treatment system for dialysis. And this is all part of the validation process. So there's around 50 lines or more for each RO installation. And you'll see that there's many number of components. For our equipment, we have installation guidelines for the pre-treatment, installation guidelines for the reverse osmosis system, and installation guidelines for the distribution loop. We then, once we've installed everything as per the installation guideline, we then do an operational qualification report. So we have the customer's name, the software versions, the service report, and then we tick any of the boxes which are relevant to the equipment that's been installed. We then have a settings report, which says when we've set the timers to start the reverse osmosis and turn the reverse osmosis off. And this is all part of your green dialysis. So by seeing this, we find out from the customer how many shifts they're running, what time they're starting dialysis, what time they're finishing dialysis. So we can refer back to this documentation at any time to make sure that the settings are correct for each installation. Remember, I spoke at the beginning, we have our validation report, which is our IQ, OQ, PQ. We have all of our pressure. So we do a pressure test of our ring mains, and our pressure test is to make sure that there's no leakage, but also that we have enough pressure to get to our last dialysis machine. We then have a device. So if we have CDS, the different permeate rings, and any concentrate rings if we have central delivery. As you know, I've already discussed that the water treatment system for dialysis is a medical device. So As such, it needs a medical device register. And in that medical device register is all of the operational data acquisition reports. That's your daily log sheet. Your microbiological. So microbiological is the actual analysis, but you also need to have a plan that goes with that. So there has to be a disinfection plan as well as a microbiological plan. We need to do training records. So when we hand over the water treatment system, we need to make sure that we've spoken to the people who are responsible. So these training records should be completed and signed off by each participant. And it protects both you as physicians, as well as the users, and as you as technicians, to make sure that your company has provided you with adequate training and documented training. And the final is the data collection, and that is your daily log sheet. So these are the log sheets. So you can create your own log sheet, or you can use the one out of the manual provided by your supplier. Finally, for the validation, we do an acceptance report from the customer. So once we hand it over, we provided the equipment, we've completed the training, and in that, once you've received a water treatment system from a supplier, you should get folders containing this. So it could be in hard copy or it could be an electronic version. And we should get the drawings of the plant room layout, the installation qualification report, settings report, daily log sheet, process flows, your medical device register, information for use manual, your heavy metals result, your bacterial results, your endotoxin results, and then a sampling plan. So this sampling plan is something you develop together, so from the supplier, as well as your own requirements. One thing I'd like to stress is that everything I've shown you here comes at no cost to you. This is just what should be provided to you. It's documentation and insurance that the equipment that's been provided has been provided as per a medical device, and it should be done to ensure your quality. Earlier on in Mr. Jarama's talk, he spoke about, there was a question to him, total cost, well, about can normal Indian clinics afford a Fresenius water treatment system? They possibly can't afford the largest or the best Fresenius equipment, but you can afford to look at your total cost of ownership from the cost of the equipment. So you have to look at your supplier. How long will the equipment last? Is it 5 years? Is it 10 years? Is it every 2 years you're going to have to replace membranes, or is it every 6 months? So the total cost of ownership has to come into your equations. So when we're looking at water treatment systems, it's not always that initial cost, it's the cost for the 5 years or the 10 years or the life of the equipment. I believe that a dialysis machine life is around 7 to 10 years. A water treatment system should be a minimum of 10 years of life. So you should have a supplier who can provide you with spare parts, can provide you with equipment that's going to last the 10 years. Because if you have to buy another reverse osmosis system in 2 or 3 years' time, or upgrade your system in 2 to 3 years' time, it's going to cost you more. So the final slide I have is from Bear Bryant, who's an NFL coach in America. It says, not the will to win, but the will to prepare to win that makes the difference. So by good preparation, by good IQ, OQ, PQ, we can make sure that we have the best outcome for our patients. So thank you very much. And if you have any questions, please.